have to consider variation of force with distance. We know there are two forces. One is the electrostatic force by using Coulomb's law. The other is gravitational force. Now, in case of Coulomb's law, the force between any two charged particle is Fc is equal to beta into q1 q2 upon r square, where beta is constant here. And in case of gravitational force also, force between two particles of masses m1 and m2 separated by some distance r, that is given by Coulomb's law, Newton's law, that is Fg is equal to capital G into m1 m2 upon r square, where G is constant. Now, using equation 1 and 2, it is clear that both the forces are inversely proportional to the square of distance between them. That means the forces varies with respect to the distance r. That is, if distance r increases, then forces decreases. In case of Coulomb's law also, if r increases, then force Fc decreases. And in case of gravitational force also, if distance between the two particles or two bodies increases, then the gravitational force decreases. The variation of these two forces with distance or separation between the particles is given in this graph. This graph shows if the distance between the two particles increases, then the forces goes on decreasing. This is the variation of force with respect to the separation between them. And it is clear that if we double the distance between the particle, suppose previous distance is 2 centimeter, for example, and if we double this distance, that is 4 centimeter, then the force decrease in force between these two particles is by 1/4. म्हणजे जर आपण डबल डिस्टन्स इन्क्रीज केलं दोन पार्टिकल मधलं, तर फोर्स कितीने डिक्रीज होतो, तर दॅट इज 1/4 ने. दिस इज द variation of force with respect to the distance between the particles. Then we have to consider superposition principle. Now, by using the Coulomb's law, we are going to calculate force between the two charges. Suppose Q1 and Q2, there are two charges and they are separated by some distance r, finite distance. Then we know, according to the Coulomb's law, the force between them is Fc is equal to beta into q1 q2 upon r square, where value of beta is calculated by using the system of unit. And here system of unit is used, SI system of unit, and then the medium is used. Beta, the value of beta depends upon the system of unit and the medium. And lastly, or in last case, we have considered only the force between two charges or two charged particles. Now, if there are more than two charged particles in a system, then we have to calculate the force exerted on any one charge. Here in this figure, I have given the large number of charges Q1, Q2, Q3, Q4, Q5, Q6, Q7, and so on up to Qn. There are large number of charged particles present in this medium or in this system. Okay. In this case, we have to find out the force exerted on any one of the charged particle. Suppose on charged particle Q1, how much is the force exerted due to all these remaining charged particles? Or we have to calculate force exerted on charge Q4 due to the remaining all charged particles. Or if we want to calculate force exerted on charge Q2 due to the remaining all charged particles. These forces or this force we have to calculate it by using the superposition principle. This is the superposition principle. Okay, now Coulomb's law gives the electrostatic force on one charge due to the another charge. Okay, if there are more than two charged particles or group of charges, then force on any one charge due to all other remaining charged particles can be obtained by using the principle of superposition. For this purpose, consider n number of point charges q1, q2, q3, q4 up to qn are situated at different points in a given region. As the force acting on any charge due to all other remaining charges is not affected by the presence of other charge. So, using Coulomb's law, we can calculate force separately for each pair of charges. That means we have to calculate, suppose we want to calculate force exerted on charge q1. Then we have to first calculate force exerted on charge q1 due to charge q2. Okay, then calculate force exerted on charge q1 due to charge q3, then calculate force exerted on charge q1 due to charge q4, then calculate force exerted on charge q1 due to charge q5, and so on. And then adding or vector addition of all these forces gives the resultant force acting on charge q1. Okay, so for example, force on charge q1 due to charge q2 is F12 bar. That is the vector form we have seen in the last. Okay, F12 bar means this is a vector and this is the force exerted on charge q1 due to charge q2. Similarly, force on charge q1 due to charge q3 is F13 bar. The F13 bar indicates force exerted on charge q1 due to charge q3. Similarly, we have to calculate force exerted on charge q1 due to charge q4, and that is equal to F14 bar. F14 indicates force exerted on charge q1 due to charge q4, and so on. We can calculate force exerted on charge q1 due to charge qn, and that is F1n bar. Okay, and by adding all these force exerted on charge q1 due to all other charges, we get the resultant force acting on charge q1. Okay, the total force on charge q1 is given by the vector sum of all these forces. That is F1 bar is equal to F12 bar plus F13 bar plus M14 bar plus so on F1n bar. In this way, we can calculate the force exerted on any one charge due to all other remaining charges. Suppose we want to calculate force exerted on charge q2, that is called F2 bar. Then first we have to calculate force exerted on charge q2 due to charge q1, then force exerted on charge q2 due to charge q3, then force exerted on charge q2 due to charge q4, and so on. And then adding all these forces, we get the resultant force exerted on charge q2 due to all other remaining charges. That is F2 bar is equal to, असं आपल्याला करता येईल की F2 bar is equal to F21 bar plus F23 bar plus F24 bar plus F25 bar plus up to F2n bar. In this way, we can calculate the force exerted on any one charge due to the presence of all other charges. This is called a superposition principle. Then we can define the superposition principle by using this concept. The superposition principle states that all the charges when placed near each other behave independent of each other, and the net force on any particular charge is a vector sum of the forces acting on that charge due to each of the other charge. This is the definition or statement of superposition principle. Okay, the simple way we can calculate the force exerted on any one charge due to the all other remaining charges. For this purpose, first we have to calculate force exerted on that particular charge due to the one charge of the remaining charge. Then force exerted on that particular charge due to the second charge out of the remaining charge. Then force exerted on that particular charge due to the third charge out of the remaining charge. Calculating all these charges, adding all these charges, that is the vector sum. Vector sum means we have to consider the sign, positive sign or negative sign. Okay, if there is a positive sign and negative sign, then there is subtraction. If there is positive positive or negative negative sign, then there is a addition. This vector sum we have to consider, and by using the vector sum we can add all these forces, we get a force exerted on any one charge due to the remaining charges. This is called superposition principle. Now let us consider one problem. Calculate the force between two balls, each having a charge of 12 microcoulomb and are 8 centimeter apart. तर या प्रॉब्लेम मध्ये आपल्याला दोन बॉल्स, चार्जड बॉल्स असतील. प्रत्येक बॉल्सवरती चार्ज किती असेल तर 12 मायक्रोकुलम इतका असेल, and they are separated by 8 centimeter apart. In this case, we have to find out the force exerted by using the Coulomb's law. Okay, now in solution, first we have to consider the given quantities. Charge on the first ball, that is called Q1, that is equal to 12 microcoulomb, and that is equal to 12 into 10 raised to minus 6 coulomb. ओके, मायक्रोकुलमचं रूपांतर आपण कुलम मध्ये करून घ्यायचंय बिकॉज वी हॅव टू कन्सिडर SI system of unit. Then charge on the second ball, that is called Q2, and that is equal to 12 microcoulomb, that is equal to again 12 into 10 raised to minus 6 coulomb. Distance between these two charges is equal to r is equal to 8 centimeter. We have to convert it into meter, that is 8 into 10 raised to minus 2 meter. And by using Coulomb's law, that is F is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square. And we have calculated the value of 1 upon 4 pi epsilon 0, that is 9 into 10 raised to 9. Okay, by putting this value, that is 9 into 10 raised to 9 multiplied by value of Q1, that is 12 into 10 raised to minus 6 into value of Q2, that is 12 into 10 raised to minus 6 divided by R square, that is 8 into 10 raised to minus 2 bracket square. And by calculating all these values, we get the force exerted on or force between these two balls is 202.5 Newton. Okay, 202.5 Newton. This much force is exerted between these two charges. Okay, let us stop here and we will continue the next.